Um, hopefully you all had a good break and you feel ready for this afternoon's session. I haven't seen any questions from earlier on our work earlier, so I'm going to kick on with the next part of the course. But just before I do that, I felt like I didn't manage to explain the differences between the srun and sbatch commands that we use to submit jobs to the Slurm scheduler adequately. So the primary difference between the two commands is that sbatch is a command that takes a script or takes a program and puts it in a queue for execution out of view. So it's kind of like sending your job away to somewhere else. It will be run, and then the results of that job are then dumped into the .out files that we saw. So you can't actually interact with that job, and you can't see what's going on in your local shell. Using sbatch also releases your shell so that you can continue to do other things on the login node. srun is a little bit different in the sense that it is used to basically run things immediately. And if you use srun, it will block any further execution on your current shell session. So you will see the output in your shell, but you won't actually be able to do any other tasks with the shell that you use to submit that srun job. Now, what might have been a little bit confusing was that in the example script, sorry, not the example script, the sharpen, what was it called? Run sharpen.slurm. We actually used sbatch to submit this job, so we were sending it away, but we used srun within the script to start our sharpen MPI program. And it might have been a little bit confusing, but what actually happens here is that srun has some smart knowledge about how to use MPI. And MPI stands for Message Passing Interface, and it is a protocol that is used in large HPC systems so that data and information can be passed between processes on different nodes, or in fact on the same node even, but running in different different processes. The reason you need this protocol is that allowing these processes to talk to each other allows them to often break up and segment large jobs. And at times where the processes need to exchange information between those segments, they are sent using this MPI protocol. And srun is a convenient way of starting MPI programs as well. The nice thing about using srun within an sbatch submission is that srun will actually inherit all of the parameters that we gave to sbatch. So it knows how many nodes it has available and how many tasks that we've allocated, and it will distribute our MPI job across the appropriate number of nodes and tasks allocated to the sbatch command that we ran. Okay, hopefully that is clear. The next section that we are going to talk about this afternoon is to do with accessing software modules, and I'm just going to paste the link to that here in the chat. So the main reason we have these things called modules is that when you're using a shared resource like HPC, or even if you're doing software development on your own computer is that certain software often has requirements to be able to run. And those requirements come in the form of environment variables, so variables that are defined within the shell. They come in the form of specific dependencies. So sometimes one piece of software will be dependent upon a version of another piece of software. And if you don't have that version, then it will break or cause errors in the software that you are trying to run. And this happens from time to time because, you know, software is an ongoing process where people are developing and improving and changing things. Software is rarely static. And so when you're on a large shared resource like HPC, a lot of users will want different versions of software to perform particular tasks that they've programmed for, which is fair enough. You know, everyone should be able to use the software that they're used to, that they want to use, that they've tested locally or that they have access to run their program. So it's generally not feasible for HPC administrators to install the same software and have it available all at the same time for every different version or every you know, type of variation that people might need to do their job. So to manage that problem, there is a package on most HPC systems called modules, and it's simply accessed on the command line using the module argument, and it has a number of sub-arguments that you can see here, sub-commands that you can use to query things about the modules that are available on your system. So what is a module? Well, a module essentially is a small packaged up bit of information that allows the module tool to load specific versions of the software so that they are available for you to run. We can have a look at what modules are available by using the module avail command, and this will print off in the less tool a long list of tables of the different types of modules that are currently available on ARCHER2. So you can see, for example, here at the top that we have some modules related to Python. So there's a netcdf4 module. This is a common file format used in meteorology and weather sciences. You've got some modules for matplotlib, PyTorch, which is a machine learning library, and TensorFlow. Famously, for example, TensorFlow and PyTorch don't necessarily work well together, so it can be a good thing to keep these two separate. You've got some core libraries here. So these are libraries that people compiling C or C++ code often need available to compile their code. And these have been specifically compiled for the architecture on which ARCHER runs. So they are hopefully optimized for the ARCHER system. If we scroll down a little bit further, we can see that we've got quite a long list of other modules that different people need access to perform their tasks. You also have a letter like a D or an L next to some of these modules, and the D here means default. So if you were just to load CPE, for example, you would get the default version, which is 21.04. But the version 21.09 is also available, so you could load that preferentially. So you can see here that we're also managing versions of software. The nice thing about modules is that some of these modules are actually dependent upon other modules within the system. And the module program knows how to interpret those dependencies. And if you load a specific module, it may have dependent other modules, and those modules will also be loaded for you so that things work. You can see a list of the currently loaded modules by using the module list command. So we can see here that out of all of those modules that we had loaded, we actually just have a small subset currently active. And these are the ones that are loaded by default, so everyone should be seeing roughly the same list. You can load modules using the load command, and we're going to use module load to load a command called ncdump. ncdump is related to the netcdf file format. And you can see at the moment that we don't have any modules referencing netcdf loaded here. So I think there's a command called which, and if you pass to this another program, it will tell you where the program is stored on the system. So currently there is no program ncdump in, and this long thing here is all the places that the computer went to look for ncdump. So this is a directory, and then that's joined using a colon to another directory. So these are all places that the shell has gone to try and find ncdump. If we were to ask it, for example, where bash is, or where the bash binary is, we can see that it comes back with /bin/bash. So this is the first bash binary that it found by looking in all of these folders. Let's see if we can get ncdump to appear by loading a module that has mcdump in it. So we should be able to load the module called cray netcdf. Oh, maybe it's not called cray netcdf anymore. Let me just check. So there is one called cray parallel netcdf. Actually, this might be a good opportunity to show you that there is a module what's it called? Keyword netcdf. So we can see that we can use that keyword command to search for modules containing a specific keyword. And there are quite a few different ones here. We should be able to load this cray netcdf. I'm not sure what was. So I have to specify the version as well. Module spider Yeah, okay. So we just had a question here about Conda. So Conda is quite specific to Python primarily. So there's a lot of packages or software that is needed by people that is not necessarily available through Conda. You also can't use locally stored modules with Conda necessarily. You'd have to kind of set things up. So module is a bit more geared towards people running C or Fortran code potentially, sort of stuff that requires compilation on the system. I have used Conda in the past on Hpc systems, and that's fine. You will need to install and set up Conda for yourself within your own project workspace generally, and then you can manage it yourself. But you then have to be aware of how you load and activate Conda environments when you execute jobs. So that's a little bit beyond what I was going to talk about today, but your system admin or help desk will probably be able to help you with that. Okay. So
one thing, if you do module spider create netcdf 4747 gives you more info about the error. I didn't know that this was like a recent change. It is because you need to load first create HDF5, and loading that it's available. This is because of we are using for ARCHER2 is a new system. Before we use TCL for modules, and now we use LMod. And yes, it's like a little more tricky. Like yeah, it's different. That's why is the error, because there is a
I have to specify the version here.
is okay. I think you don't need to.
No, default. Does that mean it's loaded? Module list?
No, it's if it's loaded, you will see an error on the.
Okay.
You needed to
Not
load
entirely
the.
Not really sure why that's not loading with one.
But if you do module load.
Oh, sorry, load. Sorry. What am I doing? Okay, no problem. Right, we can do netcdf like this.
Yeah.
Yeah. All right, I need to update the documentation. Sorry, everyone. So we need to load HDF5 first. netcdf actually uses this HDF5 file protocol underneath, so that's why this is an example of dependencies. I thought one that module would resolve the dependencies automatically, but I guess not.
To be honest, I thought so as well. I don't think on ARCHER2 there are two types of modules. I think that these modules are like let's say by default on the Cray machine, or implemented by Cray, and that's why it should load the HDF5. So yeah, I mean, I also find it. I don't understand why it doesn't load the HDF5. Thing is maybe something to solve for future releases, or not sure.
Yeah, okay. That's my bad, everyone. But thanks for bearing with me. Something for us to take away and look at, I think. Anyway, to get the nc dump command, we first need to load the HDF5 module and then the netcdf module. The cray out the front here refers to the fact that ARCHER2 is a cray system, and cray is like a company like IBM that specializes in HPC systems. Okay, so we should now be able to run the which nc dump, and we can see that we now have an executable or a binary that we can call nc dump, and that it's located in this location. And actually, the module, loading that module has actually added this folder to the path, is what it will have done, so that the shell can find nc dump. If you ever want to see the path, it's always stored in a variable called $path. We could just do echo $path, and here you can see, for instance, that these module locations have been added to the front of that path variable. If you are compiling or running software and you need that software to be added to your own path, there are lots of examples on the internet about how to set this path variable so that you can add custom folders to it. For example, in our run sharpen script, we actually did this already. So you can see here we added or we modified the path by putting in the location of the sharpen binary, which is here in our shared bin folder as part of our project. And then we just put a colon here to separate the path we wanted to add from all the other paths, and concatenated the old path variable to it. So this is sort of how we modify the path. And this is what the module file is, the module package is doing. It is adding these module paths so that the shell is exclusively loading the correct versions of the software and libraries that you need. If we wanted to see what other software was loaded with that netcdf module, we could, for instance, just have a look in this bin folder. So if you see a /bin, this is often the name of a directory that contains binary files or programs that can be executed. And we can have a look in there, and we can see that a number of command line tools have been loaded with that netcdf library, including ncconfig, ncopy, dump, and so on. We can unload those modules by using the unload command. So let's say we want to get rid of the netcdf command. That will be unloaded. Let's have a quick look at our path. We can see that because we haven't unloaded the HDF5 library, that library is still there at the front of our path variable, but the netcdf location is now being removed. So what module is doing is it is looking for the appropriate paths to this particular library that it knows about, and then removing them from the active path. Path is not persistent, so the variable path is not persistent. If you open a new shell, it will not have the modules that you have in your current path in it. So I think if I create a shell within a shell here, I now echo path. Oh no, it does actually pass them through. But I think if you opened a new shell on a node, this wouldn't be the case. So if you need modules for your particular program to run on a work node, then you'll need to load those modules as part of your SBatch scripts that you submit. There are some other things that you can do with module. So if I just type in module here, hit tab twice, I can see all of the commands that I can use. One of those is swap. So I could let me do module keywords HDF5. So we've got a 12.0.7. So I could do module swap cray-hdf5 1.12.03 and get a different version of this loaded. Okay, and gives us a little bit of feedback there telling us that it's reloaded the version. If we scroll up, we'll remember that we had 1.1203 loaded previously. And now if we look at the path, you can see that's changed to 1.1207. So we now have a different version of that HDF5 library loaded. Cool. I think that's about all we need to know. Oh, there is one last command that's useful, and that is module purge. So this will return you to the default state. So if you've loaded things and you can't remember and you need to go back to how things were, you can just use that module purge command. Are there any kind of questions about modules? I'm not sure if anyone here was intending to use some of the modules that are available. If you're just working with Conda, maybe that is another data carpentry session or something you need to discuss with your own HPC help. Well, maybe a question for you. I assume
Yes.
if people are compiling software on ARCHER2, that they will be compiling that software into the work directory or the work shared storage, and then those programs will be called from the work shared storage. Is that correct?
Yes, the easiest way, I mean, you can, you have two choices. You can download your source code to your home directory and compile everything there, and then copy the exe file to work directory. But well, the issue with that would be like maybe you will need other libraries or other files that you may forget to copy to work directory. But what I would advise is to download the source code to the work directory and compile the code there.
Yeah.
And then when you submit the job, all of these files will be available on the computer node. Oh yeah, you are
Yeah.
right. You are correct. I think that's the right procedure.
So,
I will. Sorry, just another comment. I will type in the chat that what we recommend to use on ARCHER2 is a module restore. They will give you the default modules that you have at the beginning of the session, in case that you, because
the
module
does
purge need
everything.
everything.
Okay, so restore and gives you. All right, so this is the default modules loaded. Right, so we can see in here there is some compilers. So Clang is a C compiler and some libraries maybe that are specific to those other libraries that are loaded. Yeah, so R is probably something that you would have to install yourself, I imagine, Johnny.
Is It's available. It's the thing. The module is a little bit where the name is maybe not. It's a Cray R.
Cray,
Maybe
the little one.
Is it?
Cray
Yeah,
R.
that one.
This would be a version of R that is compiled specifically for Cray systems.
Also, there is for instance, for Python, there is also a Python version is called Cray Python that actually, the performance in theory is better than.
Yeah, so Cray as a company will be tweaking the compilation options of these software from source code to make them run better on Cray systems. And that'll include tweaking like the dependency libraries and stuff that these packages have. So you could, for example, install using Conda the standard version of Python that comes with Conda, but it wouldn't necessarily be optimized to run on these systems. Yeah. An interesting thing you could do, Angie, is that you could load the Cray Python module. And I think, so then if we go which Python 3 here, you can see that we've got the Cray version of Python, and I think you can then use which VENV. That one might be all right. I think you can then use PyVenv instead of Conda to create kind of virtual environments in your own work directory. And from that, you would then have a direct reference to this particular compiled version of Python. Obviously, if you need a later version, maybe if you need like 3.10 or something, then you'd either have to talk to the systems administrator to try and get that available as a specific module, or just default back to the version that's available or compile your own.
There is in the ARCHER2 documentation some information on how to create your own environment and install your own applications in Python. We'll find the link and it in the
software libraries best practice guide. Oh, here we go, using Python. Yeah. So for anyone who is using Python on ARCHER2, here is that user guide. Hopefully, if you are not using ARCHER, your help desk or system admin can help you with some of these problems in terms of optimizing your usage on a system. So I think there was something else that I wanted to touch on while we're here. Maybe not. Anyway, does anyone else have any questions on modules before we jump to the next topic? Okay. Cool. All right. So we're moving on to transferring files to and from HPC systems. This will be a big part of what you do, particularly as you're moving data and results on and off the system. I'm going to start by exiting. Actually, I'm not going to exit ARCHER2 because I don't want to have to log in, but I will create a new local session of my shell. So this is my PowerShell here running on my laptop in front of me. And I'm just going to go into the downloads directory, and I'm going to download a file. I don't know if I have I do have wget here. I'm going to download a file from the course website called hpc introdata.tar.gz. Oh, what have we done here? Not sure if I completed or not. Oh. Let's see if that downloaded. HPC. Oh yeah, so there it is. HPC intro to data.tar.gz. I could have used some wildcards there to make my life a little bit easier, I think. If you haven't been able to download that using wget in your shell on Windows, you could also just post this URL, which I'll drop here in the chat. Go to this URL and your browser will download the file to your downloads folder directly. Okay, we already talked a bit about what a tar.gz was yesterday, so I'm just going to skip over that. And we're going to go straight to how do we copy this file to the remote system. Here, I'm going to go back to my home directory because this is probably where the file is going to go back to. It's going to do cd tilde, right? Remember that takes us back to our home directory. I'm just going to check in here because I think I already have a copy of that data, so I don't want to copy over that data. I want to demonstrate that it's arrived. So just check we remove that. The RM is removing a file. You guys shouldn't have to do that because you might not have that data already. Going back to my local laptop, the command that we're going to use to copy files to the remote machine is called SCP, which stands for secure copy, and this is a command that comes with the SSH package. And the way you copy an individual file is you start with SCP. We're going to need to give Archer the right, sorry, because I'm in the downloads directory, I need to go up a directory. I can go into SSH, and then I can give it the right key, and then we're going to specify the folder that we want, sorry, the directory that we want to, not the directory, the file, so I'm getting a bit mixed up here, that we want to send, which started with HPC. So this is the file that we want to send. Then we need to specify the computer that we're sending it to with our login credentials. So a username and the same details that we gave to SSH. And then we can specify a path that we want to put it to, including a file name. So I'm going to show you two examples. You separate the login location in username from where the file will go using a colon, and then you can just simply put the tilde to put it in your home directory. And this will now copy, hopefully, our file hpc intro-data.tar.gz to ARCHER2. We will have to enter our password. passphrase and password. And then we can see that the file was copied 100% across. If we go back to the home directory on Archer, we can now do an ls-l here. We can see that HPC intro data was copied across at 211, which was just now. We could also change the file name if we wanted to. Let's still put it in the home directory, but let's just call it test.tar.gz. We can specify the name of the file that we want to copy it to. Rerun that. Password in. Oh, it's doing this apparently. Okay, we've copied the file across. If we do another ls-l, we can see we've got a test.tar.gz, again copied to 11. So that is how you copy individual files. Obviously, you may also want to get data off Archer, in which case we have to reverse the order of the arguments. So in this instance, imagine we want to copy this test.tar.gz back to our local machine. In this instance, the first argument, this is the first argument here. This is a flag and an option. This is an argument because it's not preceded by a flag. So we're going to copy that first argument back, and then we want to copy to the current directory, so we just put a dot here. And when we run that, then we're going to be prompted for our passwords. And the file will be copied back, and we can do a local ls here and see that we just copied this back here at 213. Okay, so anyone has been trying that in their own shell and has had any problems, just let me know, or if you have any questions about that. Obviously, it's not ideal that we're just copying one file at a time at the moment, so we'll talk about some options about how to copy a number of files or whole directories, for example, in a moment. But if you have any questions specifically about this one file to and from, happy to answer questions just now before we move on to the next part. No. Unanimous silence. Okay, so another question might be, okay, why not just download files directly to Archer? And the answer is, well, yes, you can. In fact, we did that yesterday. If we just create a temporary directory called downloads, say, and we go into our downloads directory. On Archer, it's possible to run that wget command here. It's possible to run that wget command here, and Archer will allow you to download that file. But that may not be the case on every supercomputer. So there may be some supercomputers that are set up behind protected firewalls, or are limited in terms of the website domains that they have access to, or may require you to access them directly through a VPN. And those supercomputers will only allow you to upload data using a command like SCP or another application that connects using that protocol. So we're lucky in the sense that Archer allows us direct access to this file, but it may not always be the case. You also will need to use SCP if you want to recover processed information back to your own computer. Okay, what if we have a folder instead of just a single file? So I'm going to take my test. I don't know if I have tar in here. Yeah. I'm going to take my test.tar file here. We can use XVF to extract it. Actually, let's use the original. It's hpc intro data.tar.gz. So this has now extracted our tarball tape archive, which was compressed into a folder called HPC intro data. So now if we do ls hpc, you can see that we've got a directory. It's a directory on PowerShell because it's got a D here at the front, and because it has no length, it doesn't have a size. So now instead of just one file, we want to copy the folder. If we were to call SCP now, I'm just pushing it up here to go back, and I'm going to copy it into our home directory, and we're going to copy the folder. So if I remove these extensions, and we're just talking about the folder, right, rather than the file archive. So if I was just to run this, I'm really not good at entering my password. Okay. Right, so we get an error, not a regular file. So SCP here is only able to work in this mode on archives, essentially, or individual files. So this could be just a text file, or a Python script, or a shell script, or an R script, whatever you desire. But in this instance, it's not going to work if we're trying to upload a full directory. So to make it possible to do that, you actually need to give SCP another flag, which is called -r. And this stands for recursive. Recursive meaning that SCP is going to look inside the directory, and if it finds another directory, it will look inside that directory, and so on and so forth until it recurses through all the directories to find files, and those files will be transferred individually. Hopefully, it will also preserve our folder structure. Really, this afternoon, our folder structure. What is going on? Okay, so it only took 5 goes, but we got there. We'll talk about the password bit in a second. So in this instance, you can see that SCP now gives us an output where it's transferring each file that we extracted individually, and it gives us all the sizes of those files. Interesting to note here is that the overall transfer was quite a bit larger. Scroll up. It doesn't say. But was quite a bit larger than the original transfer, and it took a little bit longer because we have to initiate a transfer for every individual file, and because we've also decompressed our archive, the size of the amount of data we're transferring is much larger. Let's go back to our home directory. Let's check where we are. and see what we actually transferred in. So we can see here that we have a directory Hpc intro. So if we cd into Hpc intro data, you can see this is now a directory because we've got a little / here when we tab completed, and we can cd into it. We've now got that directory structure and all those files that we copied across. So using the -r flag on the scp command allowed us to copy across a folder and preserve its child tree structure, but in doing so we generated a process that was significantly more inefficient than when we transferred everything as a tabled archive. There's a cautionary note here in the documents, obviously, that using -r on a folder with a very large number of files can take an inordinate amount of time. So often if you're moving large amounts of information or large numbers of files on and off the Hpc file storage, it is useful to archive everything in a table before you transfer it. There are some other programs which make things a little bit more useful. One of those is Rsync. Don't know if Rsync is available here on Windows. Yeah, so I know none of you are using Linux. Linux comes with Rsync by default, and I think Mac OS does too. Rsync has some nice options in terms of allowing you to synchronize directories or folders between your local machine and a remote server. I can demonstrate how to use Rsync using my local Ubuntu terminal here. Is there much appetite to see that? Otherwise, I might show you an application called Winscp, which is available on Windows, and it's quite a useful tool for transferring smallish amounts of data across from remote file servers, particularly Hpc clusters and so forth. Okay, all right, so you've got a little bit of interest in both. One, can I just check that Macs have Rsync?
Sorry, say again?
Do Macs have Rsync installed?
I use Linux, so I have no idea. Okay, I have a confirmation from Johnny
Okay,
that
they do.
yeah.
Good. All right. So if you're on a Mac or if you're on a Linux machine, you'll have this command called rsync, and you can look at the help menu again just by using the -- help flag. There's a huge number of options here, but essentially it works in a similar way to SCP, but it provides some more useful commands. For example, and this is coming direct, so I'm going to go into downloads again here. This is where we had our Hpc folder. So for example, you can use rsync to do the same process, the recursive process, and we can give it the intro data folder, and do login.archer2. And I need to give it the SSH key. And I need to tell it where I'm going. So on the system here, I'm going to go back up to my home directory, and I'm going to go into that downloads folder. And you can see that I just have the table, nothing else. So I'm going to specify my home directory using the tilde, and then downloads, where I want to put it. So I want to copy across to there. Rsync. Oh, sorry. It should be on the end of here. Because this is just the flag for the ID file. What have I done? Maybe I is not the right option here.
Was error?
I think it's to do with the -I option. It doesn't. I'm trying to pass it the correct ID file. Or the SSH key. Nope. Give me 1 second, everyone.
I think it's a -E.
Oh yeah, -V.
Is okay. I'll
okay.
It's -E SSH, but the thing is, I don't know how you can specify the private
So
key.
you have to essentially pass those arguments to SSH like this. So it becomes a little bit more complicated because we need to specify some arguments to SSH, I think.
Okay, I found the is on the user guide. Is sorry, too many windows open.
Bad
There is at the bottom of that page, and the command is I will copy that as well. This
okay, I think this isn't going to work because this is a problem to do with Windows subsystem for Linux, which I'm running on Ubuntu at the moment. But essentially, Rsync has a number of nice options that allow you to automate some of the process of sending data across. You can still give it this -R. People with Mac can potentially try to run with this -E option to give the key correctly. If you followed my tutorial yesterday on adding information to an SSH config, potentially you wouldn't need to add this -E flag to Rsync. There's also some other good options that you can pass to Rsync, including -A option, which will automatically archive and then archive a directory or file that you pass across, so it will compress it before it sends it. You can give it the -V option, which gives you a lot more output and tells you kind of what's going on. Sorry, Z is the compression. So archive turns it into a single folder, and then Z will compress it. If you use the -P option, if your upload is interrupted, then you can use this -P option to resume uploads. So you start with the -P, a partial upload file will be saved on the server, and if your upload is interrupted, then you can restart the command and it should resume from where you finished. Sorry, I can't demonstrate that a little bit more easily here, but because I'm on a Windows machine, it's a little bit more difficult. Okay, Winscp. Hold on a second. So there is a program for Windows called Winscp. Let me just start it up here. It's available as shareware, I think, is the licensing. I can't remember exactly. Maybe it's even free. Yeah, it's free, so that's all good. Essentially, you can set up a new site. So a new site would be your address to ARCHER2, and you would put in your username, and you can put in your password. This would just be the password, and we're going to use SCP here. And then the advanced section, you would need to specify an SSH key. So if you go down to authentication, then you would need to provide the private key file. Winscp uses what are called PuTTY private key files because it uses PuTTY on the back end as the SSH protocol rather than OpenSSH. If you go all files and you select your private key file that you created using the keygen, it'll ask you to convert it to PuTTY format, and you can do that. You'll need to enter the passphrase. I am struggling a bit here. Okay, and then it will ask you to save that as a PuTTY file, so you can do that. I'll just overwrite this one I did earlier. That will then be used as the handshake key essentially with SSH.
So for interrupting, I think you have like another window open, right? A pop-up window because the
you can't see. Right, so I probably need to share my screen rather than the. Sorry, everyone.
Yeah, no worries. I mean, it happened to me.
Getting carried away.
You think that you are sharing the yeah, it's not intelligent.
Yeah.
Okay, yeah, now we.
Okay, cool. All right, so I'm just going to close this. Let's start again. So this is Winscp, and you'll need to create a new session. So you can either do that. It'll prompt you for one, or you can, what do you want to do? Go to session and then go to new session. And usually the protocol you want to use is like either SFTP or SCP. I think either is fine with ARCHER2. So then you just put in your host, which is the login.archer2 bit, put in your username and your password. What I was saying is you have to click on this advanced section, which will bring up a few options, but the main one you need to worry about is this authentication part. And you need to come down to here where it says private key file. And what it's looking for here is the PuTTY private key file, which I've already created. But if you haven't done that already, it won't be available. So you just go all files, get the private key file that you're using for Archer. So I'm just in my user directory .ssh, private key file. You can open that. It'll prompt you to convert your OpenSSH private key to a PuTTY format, which is fine. So you put in your passphrase, save it to a new file with a .ppk extension. That's fine. And then that is now registered there. So hopefully we can use that to log in. So it's still going to ask us for our key passphrase, but hopefully only once, because it'll just establish a connection with the host. And then what do we have here? I don't know if I can make this bigger for you guys. Maybe I might stop sharing the whole screen and just go back to the application. Okay, so you can kind of see two panes here. On the left, you've got the current directory on the local machine. So you can see it says C users a Hallam. And I'm in my OneDrive account, but I can go up a directory. I can go up another directory and maybe just go into my downloads. So here you can see I've got a number of downloaded files. And then on the right-hand side, I've got the folder structure available in my home directory on the ARCHER2 system. So you can see here that I'm in home TA050, so on down to my username. And if we go into like downloads, for example, you can see where I've copied the data across previously. Winscp won't archive your data, it just does like single file transfers, so you still need to put your data into archive files if possible, or this is a good way to move relatively small amounts of information backwards and forwards, but it's very easy, it's just drag and drop, so I can drag this document across and it will ask me to transfer that file, and you can see that that is now available over here. And the same thing can happen in reverse. So I could copy this demo.sh back across if I need to make edits. So that's Winscp. I imagine there is something similar available for Mac and even for Linux if you prefer to use something a little bit like this. But it can make things a little bit easier, at least initially, when you're getting comfortable with moving things backwards and forwards. Again, I want to stress, if you're using really large amounts of data, better to talk to your system admin about how to transfer it across, or use the command line and a single archive file if possible. Cool. Any quick questions about those issues? Those tools at all? Sorry, I couldn't talk a little bit more about Rsync. That would have been good. No? Okay. Let's go back to Archer. So here I'm back on the Archer system. And let's say I've finished doing some processing and I want to send some information or some data back. So we've already seen how to essentially copy something from the remote server, but let's say that I need to send a number of files and I want to create an archive. Well, to do that, you still use the tar or tar command, but you need to give it a few different options from the -xvf that we used before. Sorry, I'm just looking at the example and okay. Essentially, the example here in the documents is showing you that you can look inside an archive, such as HPC info, by using the -tf option. This doesn't extract it, but it will look inside to tell you what the contents of that file is. This is particularly useful if the file is really large and you don't want to spend a lot of time unpacking it, only to find that it didn't have what you wanted inside it. And you can I thought there was, oh yeah. Right, so the last thing I wanted to show you was that you can compress a folder typically. So we're going to compress, let's go, we're going to compress this folder HPC intro data. And the way you compress data is again with the tar command, but you change the flags to C for create. B gives us the verbose output, so this gives us a lot of information about what's being compressed. Z means we're going to use gunzip compression, and F means we're passing in a folder, I believe. And then we need to give a name to the output file that we want. In the example documents, they call it compressed_data.tar.gz, and we need to give it some inputs. In this case, we're just going to give it folder hpc intro.data. And this will essentially pass that folder to tar, and tar will create a table archive, tape archive, and apply the gunzip compression to it. So if we do ls-lat, we should see that we've now got a new archive called compresseddata.tar.gz. So that's kind of how you compress things. You could also use zip. So there's a command called zip if you prefer Windows zip files, and this has slightly different syntax to tar, but you can pass it directories as well, I think. So this would be options, zip file lists. So I think if we did zip from that folder, HPC intro data, nothing to do, recursive here. Oh yeah, -r. always the -R option, I think. No. Quick Google here, as you do. All right, similar to CAR in the sense that we need to give it the archive name first and then the input files. So in this instance, actually gives us an estimate of how much it's compressed the data as well. And if we do ls zip, we can see we've got now a zip file as well. If you want to go the other way and you're using zip files from Windows, you need to use the unzip command, do unzipped.zipped, and it will try to unzip this zip file. It's asking us whether we want to replace the folder that already exists because the contents are zipped is already present, obviously, in this. So I'm just going to go no. And no to all. Sorry, that was a bit disjointed, but does anyone have any questions about moving data on and off HPC systems before we take a quick break and move on to the final session for this afternoon? No. Okay. How about we break for 10 minutes? We'll come back at 3 o'clock and we'll do the last session, which is a little bit more interactive. Hopefully we can spend a bit more time submitting jobs to the scheduler and understanding how we can get the most out of HPC systems. Sorry, we had one question here. Clarify the syntax for path to local. Okay. Maybe it's easiest if I do that here. So there, let's get back. Trying to find the example where we copied from ARCHER2 back to this one, I think you mean, right? So you want to know how to copy from ARCHER2 like this back to the local directory dot. Yeah, okay. So yeah, so remember a dot means the current location. So dot essentially means the same as PWD. Yep, just a dot. If you want to specify the directory above, then you can use 2 dots. And you could start to build relative paths actually. So if you want to go up a directory and then down a directory again, you can specify like another directory within the parent directory. So I don't know what's above here. All right, so I should be able to do like, as I'm in downloads now, I should be able to see my SSH config file, for example. If I want to keep going up directories, I can just chain these dot dots. So this will now take me up to the C users level. So you can see in here I've got default user, Hpc Systems user, public user, and my username. The absolute path on Linux is any path that starts with a // So / at the front always means the root directory. So if I do ls / here, that's going to show me the root directory, and then I can build an absolute path that will always point to the same location regardless of where I am on the system. Remember that if I use relative paths, so this is paths that don't start with a /. Let me go back to home, for example. So just to confuse things, if I go upper directory and then have a look around, I can see all your usernames, but I can actually come back into my own home directory and see all the contents of my current home directory. So because this is a relative path, I've gone up and then come back down. In fact, you can continue to chain these together, so you could go up to the project level. So we see TO50, see all the users, and then back down to my home directory again. And this actually means I haven't moved. This is what, relative paths are useful, because they save you from having to type out the entire absolute path every time you want to do something on Linux. And remember that dot always refers to the current directory, or the current, it's essentially the same as pwd. So if I do ls dot, then I can see that I'm looking at everything in the current directory. Hopefully that answers your question. Cool. All right, I'm just going to grab some water, getting towards the end of my voice at the moment, and I'll see you back here in 5. Welcome back, everyone. Let's begin the final session for today's workshop. There's 2 parts to this. The first one is going to talk about using resources effectively. More specifically, going to give you guys a little exercise around benchmarking the sharpen script that we used earlier. And then the last little bit after that is going to discuss a little bit about how to use the resources on the shared system responsibly. So this is how to be a good HPC user. So the first session, or the first little bit we're going to talk about is available here. I just pasted a link in the chat. There's a little bit of talking here up front, but then I'm going to hand it over to you guys and hopefully give you a chance to try and do the exercise that is attached to this particular part of the workshop. So the topic of this section is a workflow that's often called benchmarking or parallelization testing. And benchmarking your code running on a cluster is generally aimed at trying to understand the parallel efficiency of the code that you're trying to run. Now, in a perfect world, let's just share a whiteboard here. Don't think, yeah. So in a perfect world, you might have, n cores. So this is the number of cores that you throw at your problem. And let's assume that your job takes a certain amount of time. And as you throw more cores at your problem, hopefully with each new core, so let's say this is 1 core, 2 cores, 3 cores, this will be 1, 2, 3. Sorry, my drawing is not great here. Let's say, and this is 2 seconds, and 1 second, and 0 seconds. Let's say that, let's go a little bit further up here, 3 seconds. Let's say, how am I doing this? That with 1 core, it takes 2 seconds to run your code. And then with 2 cores, it takes 1 second to run your code. And then with 3 cores, you know, it's like almost instantaneous. And you have this like straight line relationship between the number of cores that you throw at your problem and the amount of time that it takes. So each doubling of your cores would halve the amount of time that it takes to complete the problem. In reality, that's not usually the case. In fact, it's rarely ever the case. And the more cores you throw at a problem, the less efficient your parallelization becomes. That is, the more cores you throw at the problem, the less improvement you get with each new core. So maybe you get like a good improvement, but then as you throw more and more cores at a problem, you eventually reach a point where you get diminishing returns in terms of the improvement to the amount of time that it takes to complete your task. And the shape of this curve is generally dependent on the code that you're running, the size of the input data that you're trying to work over, and the arrangement of different hardware and systems on the computer that you're running your code. Often what we want to do is get the best bang for our buck. So we're trying to find the point where we think we're getting what we need from the code in terms of the speed up and efficiency without necessarily paying for a bunch of extra resources that aren't adding much value to the overall speed or result. Something interesting that also can happen on systems is code might actually revert in terms of efficiency when you add too many cores. So this is something else to be aware of. You could have, you know, a good speed up, but then you kind of hit a plateau, and then when you have too many cores, things go through the roof. And this is because you end up with too many cooks in the kitchen, essentially, trying to pass messages to each other and tell each other what to do. And you're reaching a point where you've bottlenecked your code. Okay, so let's go back to looking at using our resources effectively. So in this example, we're going to use the Sharpen application that we created earlier. That's the, what's it called? Sorry, the run -sharpen.slurm application from the scheduling section. And what we want to do is test this code using a different number of available cores and on a single node. So what I would like you to do is to take that script and in about 10 or 15 minutes time, we're going to, so this is the script. Don't worry too much about trying to write the script, but what we want to do is run the script multiple times by modifying the number of tasks per node we're going to run it on. And we're going to start with 1. There's some instructions down here. And we're going to run it with 2, 4, 8, 16, 32, 64, and so on, until we've tested it on the maximum number of cores on our machine, which is 256. And then we just want to tabulate the results of that. So when we run sharpen, we get an output that tells us how long the calculation took and how long the overall run took. And we want to record those numbers and see whether throwing more resources at this little problem actually improves things. Is that clear to everyone? Do I need to re-explain that at all, or is everyone happy to try and run this particular script? So here's the script if you didn't have it earlier, and you should be able to essentially submit this using sbatch. So the command was sbatch and then the script name, and that will give you a whole heap of outputs. And each time you run it, you want to increase the number of nodes you're using with 2 to the power of n. So doubling the number of nodes. I'm just going to mute my mic and come back in 10 minutes. If you have any questions or you need a little bit of help getting started, please just put some questions in the chat or raise your hand, and we can talk about what's going on. Hi, Johnny. So the output, if you're using sbatch, remember goes into a file called slurm-the job number with a .out on the end. So that's the std out from your job. Okay, have you checked the SQ to see whether the job finished running or not? It might still be in the queue if you're running one of the big tasks per node.
No, it did run, but maybe I didn't leave enough time, so maybe it actually failed.
Okay, remember you can have a look at the saccount option to see what actually happened to the job. But it should still have produced some sort of output.
Yeah.
These jobs don't take very long to run, so
Yeah, I haven't got a file called .out in my working directory.
interesting.
Did you get, when you submitted the job, did you get like a submitted job and a number?
Let's see. I can't remember what the number is. How do I look at past runs? I've forgotten now.
If you can paste the number in the chat, you might have a look.
I can't remember the job number.
You need to use either dollar user or your username. You cannot use in that to work that you need to remove the dollar symbol from that, and it will work.
You can also get a little bit slightly different output from saccount by using the -- format flag. This might be useful to see the elapsed time Samantha, did you have the, is it all jobs that are failing, or just this single one, the first one, tasks per node equals 1? Okay. Did it give you an output, like an error in that .out file?
One thing, sorry, just to mention, in case that you're having errors, I just paste a link to a share path. If you can copy there a submission script that you are using, is will be easier for us to see what is wrong on what thing could be changed in the submission script.
So you can see the output of the script that you're running by putting the @ / the name of the script file, like this. And you can see the output of the Slurm job by doing the job ID here. So usually when you submit a job using SBatch, you'll get a .out file with the job ID number in place of job ID. Exit code 127. Now, that's a new one to me. Any ideas, Juan?
No idea. I mean, I'm not sure.
Samantha, could you paste the content?
I mean, there are some info if you should have like a Slurm job ID. There is where like some more information can be found about the error. So what I can do, maybe I can create I can create a room to a breakout room and see.
Yeah, maybe.
The thing is, there is another part of the lesson, or I mean, when we will finish the exercise.
So I'll probably go through this in about 5 minutes, I think. Okay, yeah. So you need to be in /work /TO050 your username, because you can't run jobs on the worker nodes in the home directory, remember.
Another thing that this account you will have access to ARCHER2 for a month. So I imagine that you will not have time today to finish the exercises, but you will have 1 month to finish them. And in case that you have any questions or anything related to the course, please feel free to submit a query to the ARCHER2 service desk. I will type the URL, sorry, the email address, and we can help you with your job or with exercises that you may have.
I mean, exercises are always a little bit challenging doing things virtually, so appreciate everyone's perseverance and patience. I'll give you another couple of minutes, and then I'm going to quickly run through the results of running the exercise, and hopefully in the next month or so, as Juan said, you'll be able to try and do this yourself.
That means that maybe John, if you do ls, you should have a file called submit sharpen.pbs, or well, I mean the error is given because you don't have that file. So you should find the name of the script file that you want to submit. Not sure if that helps.
Yeah, maybe I'm going to essentially switch now to displaying my terminal. I'll quickly run a short example so that people might be able to do this in their own time. Just conscious that we were going to try and wrap up by about 4 o'clock today. Okay, so the first thing, if you remember from the scheduler lesson earlier, is that we need to be in the work directory. So remember when you first log into Archer, it puts you in the home directory, and the home file system is not visible to the worker nodes. So if you submit jobs to the worker nodes, they won't be able to see the script that you're referencing. So the first thing you need to do is you need to move to work, and we're just going to descend through the file system until we get to our user directory. And then in here we can write the script that we're going to write. It's called submit sharpen.pbs in this case because the original example was using a different scheduler, but the contents of the script is the same. So I'm just going to call it nano submit sharpen.slurm because I know this is actually a slurm file, but the extension doesn't really matter. In the interests of time, I'm just going to copy and paste the contents of the solution for running a single core job. So that was that section that I had up for a while there. And then I am going to write out this script and close it. I can submit the script then just simply by using sbatch sharpen.slurm. And remember, because we haven't changed anything, this is just going to be for a single core. This is the job ID here. So whenever you submit a job to sbatch, it will return a job ID. And you can see your job IDs, remember, using the SQ --me option. So this is the job I submitted. It's currently running on or allocated to this node 968. And now that it's no longer in the queue, it's finished. I can have a look at the job that I just ran by using the saccount option. The -s here just filters things back to a date. So I'm going to use yesterday. -u returns only things that are relevant to my user. So the job number that I ran was 1027259. Because that was the last job I ran, it's going to be right here down the bottom. And you can see that it ran this program called Sharpen. So that's the one that we're interested in. The Sharpen-m here is because this is concatenated. So that's what that means. We just concatenated the command that we called. Sorry, not concatenated, truncated. from that script that we ran, I do an ls-lat here, we also will have gotten an output, and it's always going to be at this form slurm dash the job ID with a dot out on the end, and we can have a quick look at what's in that by copying and pasting that file to cat. This is what we got. We're running on just one processor, so that's what we get, and we're saying that the calculation time was 3.6 seconds and the overall runtime was 3.71 seconds. Calculations here refer to the actual sharpening of the image, and the difference between the overall runtime and the calculation time is the input and output time. So that's the time it took the computer to read the data in and then write it back out to the new file. I can modify my submit sharpen.slurm now to run with more CPUs or cores. Let's just try and increase this to 2 cores. So change that to 2, write it out, resubmit same script using sbatch, have a look at the queue, see where this is at. Still running, finishing up, done. Okay, and I can have a look at the output of that job. So remember, the output files are going to be slurm dash the job ID, which I got either from when I submitted the job or by looking at the queue, and it's going to be the most recent one. Okay, so here the calculation time is reduced. It's now down to 1.8 seconds, and the overall time is 1.93. So it's about 0.1 of a second for I/O, which was about the same as it was for the previous process where we had just one processor versus 2 processors. Essentially, the idea is that we repeat this process for 4, 8, 16, and so on cores, ideally getting improvements in the calculation time. Out of interest, we had 3.6 seconds for 1 core of processing, 1.8 seconds for 2 cores of processing, so that's roughly a speed up of 2, right? So 3.6 divided by 1.8 is about 2. We halved the amount of processing time by adding a second core. What you'll find with this job, if we go back to the exercise, is that if you run this process with an increasing number of cores, so we were going to fill out this table running this process for more and more cores, is that you do get a speed up, but the amount of speed up that you actually achieve begins to diminish. So we can see here that the calculation time is reducing, and if we take the calculation time and divide it by the number of cores, we get the efficiency essentially per core. We can see that actually the efficiency starts to diminish after we go beyond about 4 cores. So here we're not really getting any speed up at all from having the additional cores available. So in this instance, for this particular problem with the data size that we've got, it probably wouldn't make sense to run this problem on any more than about 4 cores. If we had a larger number of, or a larger image to process, we would spend more time processing that data and therefore we probably would benefit from having a larger number of cores. But this is the type of benchmarking that you ideally would be doing to your data set before you scale it up and run your full either simulation or statistics processing or algorithms on a worker node. You can then kind of gauge what is the best overall resource allocation for your specific problem. I'm going to skip through this last little section here, which sort of talks about some measures for parallel efficiency and speed up. But I think this is relatively straightforward, so I'd suggest you work through this in your own time and submit any questions if you have any. A few tips for running benchmarking. Sometimes the objective of running our code on the Hpc systems are different for different tasks that we're trying to do. If you're trying to be efficient, then you might choose to take a little bit more time to run your computation at the expense of being able to run more of them. So for example, let's say you want to run 10 different versions of your simulation, and you could run them in 10 hours on 10 cores, or you could run them in 8 hours on 20 cores. It's probably more efficient to stick to the 10 core option and run more of your jobs simultaneously than it is to try and run one job just 2 hours faster. Alternatively, if you just have a single job, or you're running to a deadline, those additional reduction in the runtime might be very important to you. So in that instance, you might choose to consume a larger number of cores to improve the turnaround on your projects. Other things you can do when you're benchmarking, you can reduce the size of the data set that you're benchmarking. So it doesn't make a huge amount of sense to run your benchmark on your full data set. So you're basically running the code anyway. So choose a relatively small set and choose meaningful computation times. So maybe you want your computation time to be about 5 to 10 minutes. That'll probably give you a reasonable idea of the efficiency that you're getting out of your program. As we did for this program, if you can, you want to exclude the I/O time. So that is the time it takes to move your data into memory or out of memory from the computation time, because the computation time is where you're seeing the overall parallel efficiency. All right, we've only got about 15 minutes left, and fortunately that's just enough time to cover this last section. Before I move on, are there any kind of last questions on that exercise? Hopefully running through that in the shell there sort of helped people a little bit in terms of getting started. Okay. Okay, so this last section primarily just talks about how to be a good user on a HPC system. You've got to remember that you're not the only person using a HPC login node. And even the worker nodes can sometimes be shared on certain systems. So if you're only using half the number of cores on a worker node, the scheduler sometimes might allocate the other cores to someone else. I think someone earlier in the week was talking about having to specify their memory usage. If that is the case, that's often an instance where the scheduler needs to know how much memory you want so that it can specify a node to you that has the available amount of memory and cores, particularly if you're sharing both that memory and those cores with another user on the system. This is obviously very different to if you're working on your own private desktop or your laptop, where the resources of that system are available to you and at your disposal all the time exclusively. Schedulers, it just makes a note here that schedulers are kind of the natural outcome of having these shared resources. If there was maybe only 2, 3, or 4 users on a small cluster, you could probably talk to each other and manage the job load of that cluster effectively. But as the number of users increases and the scale of the resources increases, you really need software to be able to manage and administer the resources to users and jobs fairly. Big one here, be kind to the login nodes. So we've talked about this pretty extensively already, but login nodes are where everyone ends up at the start of their process to get started on a cluster. The login nodes are probably the most shared resource on the cluster, and so you need to be conscious of what you're doing and try to avoid overloading those login nodes as much as possible. They're often monitored on really large HPC systems, and people will be in touch with you if they think that you're abusing those resources. More importantly, it's a pain when something happens to a login node and it goes down because a user hasn't been following the rules or respecting what is required of the cluster and its policies. There's a few tips here. So we talked about top earlier. There's another command called PS with the UX argument, and this will list basically all the processes that are currently running on the computer. There is the option if you start a process and it gets stuck, or you want to kill it before it finishes, you can use the Control-C option. If the shell has become a bit locked, you can try to log back in a new shell and use the kill command essentially to kill the process IDs. This PID stands for process ID. You'll see when you start top, so I can just start top over here. So you'll see when you start top that the first column here is the PID. So if you have a process that's stuck at 100% or more and it's doing something that it's not meant to and you want to kill it, in another shell you can type kill and the PID, and that will hopefully halt that process on the server. Don't worry about other users. You should not have permissions to kill processes that belong to the root in particular, but also to other users. You'll only be able to affect ones that are your as a result of you starting the process. Okay. There's a quick little exercise here, which kind of gives you a bit of food for thought. Essentially, login nodes should be reserved for kind of routine tasks related to data and the compilation of software or the setup of software that you need to run. If we work through these examples here, these are examples of commands that people might be able to run on a login node. But the question is, should they be things that are run on the login node? The first one is a call to Python and a script called physics_sim. So this looks like essentially someone is trying to call a simulation model, which we would usually probably describe as work. The second command, make, is a common command used to compile software. The third command is a shell script. Remember, .sh usually refers to a shell script, and the script is titled create directories. So this is probably creating a directory structure. The fourth command is a program called Molecular Dynamics 2. So this is probably some other type of modeling. And then the fifth command is a call to extract a tar.gz archive. For my money, I would say that running a simulation model on the login node is inappropriate, and running a program which also looks like some sort of modeling on the simulation node is inappropriate. Make, so compilation of software, is fine as long as it's not too excessive. Create directories.sh, so you're just creating a file structure, that's fine. And unzipping an archive is also fine. So we can see that the solution here agrees with us that we probably shouldn't be running Python or custom molecular dynamics code on the login node. Remember, if you want to do testing or if you want to trial something, you can always do small tests using the short queue, or you can use srun, as I showed you earlier, to get a worker node in a interactive session, and you can do things there. This is a big one, and it goes back to the benchmarking that we were doing before. Do a little bit of testing before you scale your problems so that you understand how parallelizable your code is. It's no good to anyone if you run a job for 24 hours on 1,000 cores, but you requested 2,000 cores by mistake, and specifically if you only use like 100 of the 1,000 cores you thought you would need, but 2,000 you actually requested. In this instance, not only will you be paying for the 2,000 cores that you requested by mistake, but you'll also be woefully inefficient in the way that you're using them. So you'll be paying for a resource that isn't actually benefiting you at all. Doing those benchmarking tests and trialing things at the beginning can seem like a little bit of a pain in terms of getting started, but in the long run it will help you make the most of the HPC system that's available to you, and particularly reduce the amount that it costs you to run these processes. Okay, the last little bit here is about data. So depending on your HPC system, they may or may not offer various degrees of backup when it comes to data. So this includes both the software that you build and compile and new environments that you make on the system, and the data that you transfer to, create, and summarize with your code. Ideally, you should be taking it upon yourself to back up the data as often as you can. So if you run a job and then you're happy with the results, it's pretty much a good idea to immediately copy that back to your own local storage where you can look at it further or do further analysis, or to your own kind of archive storage where you can keep it for future use or reference. When it comes to code that you're writing, if that code is something that you're editing on the cluster itself, if that cluster has access to the internet, you can often use version control systems like Git. An example of that is like GitHub and GitLab. So the University of Edinburgh here has its own instance of GitLab that you can back up your code to. Version controls, not generally for large amounts of data, but it is good for saving versions of scripts that you might have created or software that you're working on. That's a little bit beyond this course, but there are other data carpentries available that will teach you all about version control and how to write good software if you are interested in those kinds of things. And a good last tip here, sometimes your access to a HPC system will be time limited. So if you're working on a specific project and that project has a contract with the HPC provider for a certain amount of time, it may be that you'll find your project directories are removed a certain amount of time after that contract ends. So it's very important that you're aware of and manage those relationships that you have with your HPC provider. On smaller clusters, this might be less of an issue, but for something the size of ARCHER2, which is shared by such a large number of users, this is a really important thing to be aware of. And this is a big point. Your data is your responsibility, right? So the HPC systems people will not take ultimate responsibility for your data. Their obligation is to provide the service and make sure that the compute is available as allocated to you in the agreements that you have with them. A couple of things to consider when transferring data. There's two concepts that we need to be aware of. One is bandwidth and the other is latency. You can think of bandwidth basically as being the size of the pipe that connects the two places you want to send data. So the bigger the pipe, the more data you can push through it in a given time. Latency is a little bit more subtle, but essentially it talks to issues associated with the data transfer. We observed this a little bit with SCP earlier today. Latency would refer to the time it took for SCP to make a connection to the server and then to transfer the file. When we transferred a single archive file, there was relatively little latency because we only had to make that connection and do the file transfer once. Whereas when we transferred the full directory, we introduced additional latency because we had to re-establish a transfer connection for every single file that we transferred. So there are some things that you need to be aware of when you're doing these kinds of file transfers. In terms of performance on HPC systems, there's a couple of things that can affect your data I/O. So when you're working on a HPC node, it obviously needs to go away and grab the data that you want for input. If your input data or your configuration for your model is very small, then this is rarely ever an issue. But if you're trying to consume a large amount of data, then you may be interested, for example, in the disk speed of your HPC system. Some HPC providers may have special disks that provide much faster access for particular I/O intensive data tasks. And you need to be aware of the network speed. So some different types of storage may be attached to different parts of the system with different types of network transfer. I mean, here specifically, they're talking about transferring data from your laptop or workstation to the cluster. If you're trying to transfer a large amount of data on your holiday Wi-Fi account while you're overseas, you may find that that takes an inordinate amount of time. Whereas if you had done it while you're in the office, connected to a gigabit local area network that was directly plugged into your HPC cluster, then it would have been, almost instantaneous. So you need to sort of be aware of these issues and understand the best ways that you might go about moving data in and out of the system. I'm going to skip over this last section, and that basically brings us to a conclusion. It's now 4 o'clock. I am happy to stick around for a half an hour if people want to go back to the exercise, or if you have other questions, maybe something specific about the problem or about HPC in general that you don't understand or you would like a bit of clarification on. I hope you've enjoyed yesterday and today's session and that you got something out of this carpentry course, feeling a little bit more confident and comfortable about using the shell and how you might approach the HPC system and the HPC systems in general and your HPC system locally. Always, if you have questions about a particular HPC system, reach out to the admin and help desk attached to that system, and I'm sure they'll be more than willing to help you solve your computational problems. If you have any feedback, otherwise, feel free to mail it through or leave it in the chat. It's been great having you all here, and I hope you have a lovely weekend.